Eric Darling here with Darling Data, and I'm going to be recording my session from PASS Summit 2024. Everything you know about isolation levels is wrong. It's going to be over about 10 parts. I think just to split things up fairly and to make sure that each demo is sort of accessible and findable and, just makes life a little bit easier on the folks who want to watch this so they don't have to have like an hour 75-minute video where they're just trying to hop around and figure out where things are. So I'm going to break things up over about 10 videos and get those done. So the thing that I want to sort of get across in these, probably everything you know about isolation levels is wrong. A lot of people start their assumptions about isolation levels in a really bad place, and where we end up from there is where we have a building with a very shaky foundation. So the things that I'm going to go over in this video are to sort of teach you about just how flawed read committed the default isolation level in SQL Server is, and talk to you about some of the differences between the different isolation levels, sort of specifically comparing like isolation levels to each other. So comparing things like repeatable read and serializable, comparing things like read committed snapshot isolation and snapshot isolation, and we're even going to talk about everyone's favorite subject, no-lock. Now, the big thing about no-lock is that everyone loves to dunk on no-lock. Everyone loves to, which is a synonym for read uncommitted, so they are the same thing. You use no-lock, you use read uncommitted. What I want you to understand is that it's very easy to dunk on that. But the problem isn't no-lock. The problem isn't read uncommitted. The problem is read committed. The reason why everyone jumps to those worse isolation levels, using no-lock, hence using the read uncommitted isolation level, is because of all the problems that you find under read committed that people want to get away from, very specifically locking, blocking, deadlocking between read queries and write queries. Read committed is a very shamefully bad isolation level. And it hurts my heart to say that it is the default isolation level for SQL Server, especially when it's not the default isolation level for Azure SQL DB. As soon as Microsoft started having to host customer workloads, one of the first decisions they made was, by default, every database that gets created here is going to use read committed snapshot isolation. So what I really want to get across in these is that if you are using read committed the default isolation level, and you're hitting lots of locking and blocking problems, rather than be tempted to use no lock or read uncommitted, which again are synonyms for each other, you would be much better off using an optimistic isolation level that solves all of the locking and blocking problems you're having without the potential for introducing dirty reads. I'm going to talk about that in a lot more detail as we go through things, but just sort of to get things kicked off, this is the stuff that I'm going to walk through. At the very end, there will also be an example of a query where using an optimistic isolation level does introduce one of the race conditions that some people talk about, but it is not a dirty read. What a lot of people get really confused when they start reading blog posts about different isolation levels, especially the optimistic ones, they think that they can do dirty reads, which they absolutely can't. They also get very confused because there are all these blog posts out there about marble colors not being the same or the right color when different transactions run. The problem is that those blog posts don't really give you the right information, or people don't really take the right information even if it's there in these blog posts. That like the update problem is usually a result of snapshot isolation, not read committed snapshot isolation. Snapshot isolation is the one that can have modification queries work and sometimes even run into conflicts when two modification queries try to run and work on the same versions of rows. But read committed snapshot isolation doesn't allow that. Now, a lot of the demos that are in this session are things that I have actually recorded on this channel before, but they're all going to sort of be together now in a nice cohesive playlist where you're going to be able to see all of them find the ones you really like, find the ones you want, and they're all going to be under the Everything You Know About Isolation Levels is Wrong playlist. So everything will be nice and easily accessible there as the videos become live over the 10 or so days that they'll be published. I think that's about it. I hope that you enjoy these videos. I hope that they are plenty illuminating for you, and that I really hope that what I can do for the SQL Server community writ large, as they say, is to help convince more vendors, stakeholders, application owners, people in charge of these things, that an optimistic isolation level is a far better choice than either using read committed and just throwing your hands up at locking, blocking, and deadlocking problems, or like just ending up using a bunch of no lock hints or using read uncommitted as an isolation level, because those are often very, very inappropriate for any query results that you can possibly imagine. So I'm gonna hit finish on this one. I'm gonna start the uploading process, and then over the next, again, look, 9 more videos after this, I'm going to be going through the material from the rest of the presentation that I went through during PASS. Probably some fewer contextual jokes than if you caught the session live, but I don't know. It'll be fun anyway. All right, cool. Thank you for watching. I'm going to get moving on this next video now. All right, beautiful. You're beautiful. I couldn't do this without you.